Howdy howdy, this is Mr. Potter. In our last video we saw how we could take pixels and manipulate the colors in a particular pixel to get different images. We saw how we could eliminate one color from a picture, we could reduce a picture to one color or even make it black and white, and we saw how we could do some manipulations with that respect. But another thing that we can do with these photos is we can actually copy the pixels from one area to another. So I've got a method here called mirror vertical. And what it's going to do is it's going to take an image and basically copy the top half of the image to the bottom half of the image. And so what I want to do is I want to take a look at what this actually does. So I've got my test mirror vertical. It's going to load a picture of a caterpillar. We're going to explore it, we're going to mirror it, and then we're going to explore it again. So I'm going to go down to my main. I'm going to copy out or comment out the test negate that we were working on last time. And I want to go to test mirror vertical, and we're going to run this and see what happens. And so what happens is I have two images here. One image is I just have my original caterpillar image. But what we have over here is that we've actually copied it horizontally. In other words, the caterpillar which was facing left now has a face over here that's facing right. And we can see that basically for this line down the middle, everything to the left of this line has been copied over to the right side of this line. So I want to talk about how we actually go about doing this. So going back to our method, this is something that's not really that different. We saw last time how we would basically ask our class to get a two-dimensional array of pixels, which we would then traverse. But this time, instead of just taking one pixel and manipulating its color, what I want to do is I actually want to traverse a left side of this graph and the right side of this image. So I've got left pixel and right pixel, both of which I'm starting off at null. And what I'm doing is I'm figuring out what the width is. My width is, of course, remember that when we're dealing with a picture, it's rows and columns. So my width has to do with the columns, and it's going to be the length of one of these rows. In particular, row 0 is probably the easiest one to work at. So that's why we have pixels sub 0 dot length as our width. Now, in our image, we only want to go halfway across, so our loop is going to stop at width divided by 2. But we're going to do that for every row in our picture. So notice row goes from 0 to pixels.length. So it's going to go from the top of our image down. But the columns are going to go from the leftmost side of our picture only to halfway. And what's going to happen is I want to copy whatever's on the left pixel, and I really want to put it on the right pixel. Now keep in mind, if I'm copying the first column, which is column 0, I want to copy it to the last column. And my last column is width minus 1. So the third column on the left would be 3 columns away from the right side. So that's where we're getting this width minus 1 minus col from, because it's width minus 1, that's our rightmost edge, minus however many columns we're in. So if we're 20 columns in on the left, I want to be 20 columns in on the right. So I want to take 20 away from that. So I'm saying let my left pixel be equal to whatever that pixel is at that particular row and column. This is on the left side of the graph because col has to be less than width divided by 2. And I want my right pixel to be the corresponding pixel on the right side of this imaginary line that I've drawn. And I'm telling my right pixel to set its color to whatever the left pixel's color is. So let me go ahead and rerun this again. What that means is this pixel here, which is red, gets copied over to a corresponding pixel over here, which is also red. Notice that that pixel wasn't red over here at 25,294. Let me go ahead and get there exactly. 25 and 294. Remember that pixel was white, but when I copied this pixel over, it became red. And so the act of copying the color of each of these positions actually copies the image that we see produced by those colors. So we've got the red circle in the black, the red shaded area inside the black circle. That's copying the colors, but it also ends up copying the image for us. And I have this imaginary line down the middle, and I can't really notice the line here, but I see it really well here because this place right here, let me zoom in. But if I zoom into the middle, which is right here, you can see that I've got this really sharp corner. And this corner wasn't part of the original design. keep in mind what's happening here is that that little hump is being cut in half, or it's being cut into a part. So I only see this left part of this hump right here. This part here is being copied to here. So that's how we're copying from the left side of my graph to the right side of my graph. And we call this test mirror vertical because we have a vertical line that's running straight down. So what I want to do is I actually want to try and do the same thing, but with the test mirror horizontal. So I want to do the same idea. Let me go ahead and scroll this up. So I'm going to have public void mirror horizontal. And so what I'm going to have to do is I'm going to have to, again, get an array of pixels. So pixel matrix pixels. Pixels gets this dot get pixels 2D. And instead of having a left pixel and a right pixel, I'm going to want something from the top of my image that's going to copy to the bottom of my image. So I'm going to have a pixel top pixel, which is going to get null, and pixel bottom pixel, which is going to get null. So I'm going to be copying from the top to the bottom, but I'm interested in some height. In other words, I'm going to copy the top height to the bottom. In other words, row 0 is going to be copied to the very last row. Row 1 is going to be copied to the second to last row. So I need to determine what my height is, and that's really equal to the number of rows. In other words, that's the size of pixels. So pixels dot length. So now what I need to do is I need to go row by row, but I'm not going to do all the rows. I'm going to start at 0, row 0. But I want my rows to be less than height divided by 2. And of course, row plus plus. Because I don't want to go all the way from the top to the bottom. I want to copy the top to the bottom, so I only need to go halfway. Once I reach the halfway point, I'm actually copying elements to themselves. Of course, inside this loop, I'm going to have call gets 0, call is less than the width. But the width is an entire row of this pixel. So it's going to be pixels sub 0 dot length and call plus plus. And so this series of nested loops allow me to completely traverse the top half of my image. The top half because my rows only go down to halfway of the height. But I'm going from the leftmost column to the rightmost column. So I'm going to let my top pixel be equal to pixels at row and at column because I'm traversing the top half of my graph. But my bottom pixel needs to be the corresponding pixel in the bottom half. So my row is actually going to be from the bottom up. So the bottom of my graph is height minus 1. And if I'm starting 4 rows from the top, I need to be 4 rows from the bottom, so I need to subtract row from that. And then call as well. And then I want to say bottom pixel dot set color to left pixel dot get color. Now remember that the get color method actually gets a color object, and then we're passing that color object left pixel. I mean top pixel. That's horrible. I need to fix that. This should be top pixel. Anyway, top pixel dot get color returns a color object, and I want to pass that object as a parameter to set color so that I will end up setting the color of this mirror horizontal method. So we're going to compile this, make sure we don't have any egregious errors. And then I need a corresponding tester. So I'm going to comment out test mirror vertical, and I want test mirror horizontal. And so I need to write that test mirror horizontal. So it's going to look a lot like this test mirror vertical. I'm going to actually just copy this method and paste it. But we're going to call it test mirror horizontal. And we're going to call on the mirror horizontal method. So we're going to copy that. And so I end up with 2 pictures. Notice that the first picture just has the bug at the top of the leaf. Over here, I've got a bug on top and I've got a bug on bottom, and I've got this line across, which is my mirror image. By the way, notice that this line, this horizontal line, is actually off center. It's actually a little bit below the halfway point. And I can tell that because the green from above, the green from this top part of the curve, got copied down to the bottom. Also notice that I kind of have a really smooth ellipse shape on the sides, but over here it's a much more corner aspect to it. So we've copied from the top to the bottom. Now it's really easy to do this for a grand swath of an image. In other words, if I want to copy the entire left side to the entire right side, that's great. But if I want to copy just part of an image, I have to do it a little bit differently. So I'm actually going to run a different method now here. I'm going to go ahead and close these little windows. I'm going to comment out the test mirror horizontal, and I'm going to uncomment test mirror temple. And what this is going to do is this is going to take an ancient temple and show you something's happened to it. So I've got this ancient temple. This is actually after we've done the copying, because the original temple was in some ruins. So because the temple had these ruins here, we kind of needed to fix this. But I don't want to fix the whole thing. I don't want to copy everything from the left side over to the right side. For one, I'll lose this person over here. I only want to copy this part of the top of the building. I want to copy it so it's a nice smooth transition down to here. So I don't want to go from the top row to the bottom row. I really only want to kind of go from this row to this row. And I don't want to copy the whole width of it. I kind of only want to copy from here to some middle line, some median line. And so I want to talk about how we do this. So let's go ahead and take a look at this. So we're going to go ahead and trim that down. We're going to go back to our picture class and take a look at this mirror temple. Notice that we have a mirror point of 276. This number seems rather arbitrary, but we're going to talk about where this number comes from. This number is actually a column. And so if I go back and run those pictures again, just so I can have them up, I'm not sure why I closed them. But if I go over here and I want to look at my picture at position 276, and by the way, 276 is a column. So if I go over here to 276 and I zoom in, you'll notice that 276 is right at where the corner starts. It's actually at the left side of the corner. And so these are the points that it's going to be the dividing side between the left side points and the right side points. But the other thing to notice is that I don't want all the rows. I want starting at row 27, excuse me. Notice right now I'm at row 15. So if I increase this to row 27, you see that this is actually where we start copying. From row 27 all the way down to row 93. So I have to keep scrolling down. Row 93 is right there. So in other words, this horizontal line is really where we're stopping the copying from. I'm only copying from this row to this column. And similarly, I'm only copying from column 13. Column 13 is around here. So in other words, only this column over is being copied. I'm not changing anything on this side. And that means the corresponding columns over here won't change either. Something else that's important to notice, and that you really can't notice unless I zoom out, is that this isn't a centered picture. Over here in this corner, let me get into this corner. Can I get over here to find out what my rightmost column is actually position 567. If I take half of that's not going to be 276. Half of that's going to be 283. So this isn't centered. And that's something that you need to be aware of as well, is that the region that we're copying doesn't have to be a centered region. It just has to be from the left side of some point to the right side of some point, or from the top point to the bottom point. That's what makes the mirror. So let's go ahead and investigate what we've done here. So I've got int mirror is 276. Pixel left pixel is null. Pixel right pixel is null. Int count is 0. And then I've got my pixel matrix. Now I'm doing this count I'm not sure why this count is here. I mean, we don't really use the count here. I think it's completely extra. But what we're doing is we're starting at row 27 and we're starting at column 13, and we're only copying the part of the top of this building that we want to copy. But we're doing the exact same idea here, that we've got row column, that's for my left pixel. My right pixel is going to be my mirror point minus my column, and that actually, if I do that, I'm going to have my mirror point, which is 276, which is here-ish, minus my column. That's going to move it here, move it over 8 columns. But then I want to translate it plus mirror point, which is going to translate it over this way. So it basically shifts it over here. So the appropriate points get copied where they need to go. And so that takes care of this image. The only problem I have is it certainly appears that they need to mow the grass. This little thing right here is bothering me. I'm not sure why we've got this huge weed here. It'd be really nice if we could kind of copy this column over here the same way that we copied this part of our building over. So I'm wondering if we could do that. So let's make a method, and let's call this method public void mow the lawn. And so what we're going to be doing here, the objective of this, and what I want to do is I kind of want to get rid of this tree. So I need to investigate. Let me zoom in to see where this tree actually is. So we're going to scroll over, and we've got this wild shrub that we need to get. I think the highest point that I'm looking at is I'm looking at something that's basically at a row 259. That's going to be the highest point. In other words, that's going to be the smallest row. So row 259. And then I want to keep going down until I hit somewhere around here, well into this grass, which is row 329. So in other words, I'm going to make sure that my rows go from 259 to 329. And I definitely need to make sure that I can copy up to this 360 because I need to make sure that I can copy all this leave. So let's go ahead and say 328. That's going to be as far as I want to copy. But what's important is that I know how far it is till I actually get to the column. Notice the column actually starts here at 342. So I'm going to want to make sure that my column gets matched by a mirror image of the column, which should be there at 212. So in other words, I want this pixel at 212 to be mirrored to the 342. And if I take the average of those, so I'm going to take 342 plus 212, that's going to add up to 554. And when I divide by 2, that's going to be 277. So in other words, for our purposes, I want my mirror point to be 277, which works out really nice because that's our mirror point up here. That's kind of the center of our temple. So I'm going to go ahead and say int mirror point gets 277, and I'm going to say pixel left pixel gets null, and pixel right pixel gets null. And I'm not going to worry about that int count gets 0 because I don't see it being used here, but I've got pixel matrix pixels gets this dot get pixels 2D. And this is pretty much standard. We've done this on yesterday's lesson and we're doing it on today's. And then I want to go through the rows, but keep in mind the rows that I want to go to are from 259 to 329. So for int row gets 259, row has to be less than 329, row plus plus. And then my columns, the first column that I had was 212. So for int col gets 212, col is less than mirror point, col plus plus. And so what this is going to do is this is going to traverse through the left side of this. So if I zoom out a bit, this is going to go through the left side of this middle line, and it's going to copy this part of my pillar to this part of my pillar. That way I'm going to have a nice copy over. And then what I need to do is make sure that I copy all those points. So I want to say that left pixel is going to be pixels at row and at call. And my right pixel is going to be equal to my pixels, have to be on the same row, but my column is going to be my mirror point minus my call plus my mirror point. I'm emulating the code that we have up here because I want to take my mirror point, but I want to shift it over that same number of columns. If I'm 4 columns away from the left side, I want to be 4 columns away from the right side, plus mirror point. And then I just copy the color. So right pixel dot set color, whatever left pixel dot get color. And so we're going to see how that works. So I'm going to compile this. I don't need that running anymore. We're going to compile this. Hopefully I don't have any massive errors, just one. And it says that it doesn't know what mirror point is because I shouldn't have capitalized it. Sounds like a plan. So now that's good. So now what I want to do is I want to comment this out. And I want to write a method called test mow the lawn. And so we're going to copy our temple up here. So copy this mirror temple. And so this is test mow the lawn. And I want to do my mow the lawn method. So let's compile this, make sure it works. Good, and run it. Let's see what happens. So what we've done here is we tried to copy this pillar over here, and we did this. Now notice that we no longer have that problem. That tree has been taken care of. Mostly, I can still see some remnants of that. So I'll definitely need to take care of that. So the reason is because I started at this column, and so I only did up to this column. I really need to go about another, let's see how many pixels. Let's zoom in. Let's zoom into here. So the thing is, that's 343, and I really want to be about 14, 15 more pixels away. So let's make that little tweak because I don't like having hanging leaves. So go back to my picture class, and we want to be about 15 more pixels away. So let's go ahead and make this 198. Of course, I'm not changing the middle. The middle should still work. So we're going to go ahead and run this again. And I should get a better picture this time. And notice that I no longer see those leaves over there. In other words, all the leaves have been taken care of. And I've just got a little bit of, an issue there. But if I really wanted to, I could copy from the entire top of this pole. In other words, I could copy from this line. Let me go ahead and zoom in here and find out exactly where that pixel is. So I could copy from right here and make sure that these tops actually get copied as well. And I'd see a nice smooth transition. That's row 159. So last time we're going to run this, let's go ahead and stop that. We're going to go to row 159. And we should be able to compile that. And we'll run this. And so now we've got, instead of having a little break here, instead of having a tree, we actually have a nice smooth pillar all the way up to the top. And unless you really took a close look at it, you wouldn't really notice that the water stains over here or the lime stains are copied over here. It's a pretty good thing, and it's a pretty neat trim here. I could actually extend the row down a little bit more if I wanted to, but all I'm doing at this point is just adjusting the parameters. All I'm doing is I'm tweaking where my rows start and stop, where my columns start. All I'm doing is tweaking those to make sure that I cover everything that I need to. And this actually gives us quite a bit of control. A lot of people do photo manipulation to get a desired effect or to clean up artifacts in an image, and it can be done electronically. As a matter of fact, a lot of times it is done electronically through programs like Photoshop or GIMP that allow you to basically take a good area and put it over a damaged area, or to put it over an area you really don't want to see. And that's part of the power of this computer programming, that we could take data from a picture and copy the data in such a way that it produces a new image. It produces a favorable image. So once again, this is Mr. Potter. Thank you for watching. Have a great day.